Hey everybody, welcome to the video. In this video we're going to cover flashing the firmware for the High Nibble IMSAI 8080 emulation system. This video will also apply to other ESP32-PICO-KIT systems and should generally apply to the ESP32 as well across other platforms. So before we jump into the video, I need to make some corrections. During editing I noticed some things I just plain got incorrect. So these items will be specific to the IMSAI 8080 emulation system from the High Nibble. If you're here to just program an ESP32 and looking for information on how to do it in Windows, this won't apply to you. So the first thing is a discussion about NVRAM. That's the non-volatile RAM that the emulator uses to store configuration information. On the High Nibble's website, you'll see a section where he talks about getting into the NVRAM and using the front panel switches to set configurations. These configurations are like what ROMs are installed in the system, the CPU that's being used, 8080 or Z80, the CPU speed, 2 megahertz or 4 megahertz, whether your Wi-Fi connection is an access point, or I don't remember the name of the other mode. Anyhow, so let's jump in first, talk about the NVRAM. In the video, I state that during the flashing process, the NVRAM contents are lost. This is actually incorrect. You probably should read through what the High Nibble's website where you go to download the firmware. We'll discuss that later on here. If you're coming from an older version of the firmware, there's a process you need to go through so that the NVRAM stays compatible with the current firmware. And his website talks about that. As you upgrade through versions, you should keep that information in mind. So the contents of the NVRAM actually are not lost when you flash the ESP32-PICO-KIT. I state that it is in the video. It's not. So you need to keep that in mind. The second thing, just to make really clear, is if you take the image zip and you replace the contents on the micro SD card, you can lose content. You actually probably will. If you've been running CPM and you've been editing a document, doing some programming or whatever, those changes are persisted in the disk images on the micro SD card. If you completely format and replace the contents on the micro SD card with a fresh copy, you will lose those changes. So you don't necessarily have to format and replace the contents on the micro SD card. It may be that you can, fix a firmware issue if you need to, or update the firmware, and your existing micro SD card contents will be absolutely fine. So keep those things in mind, because I will misspeak a couple of times throughout the video. I apologize for this. I'm not going to go back and reshoot those sections. So like I said, keep this in mind. So let's jump into some of the details here that we'll need to know ahead of time. So like I said, we're going to look at flashing the firmware on the ESP32-PICO-KIT using Python, specifically the ESP Python script. This gives you kind of the lowest level way to connect and get firmware onto the ESP32. The High Nibble emulator, when it's fully up and running, allows drag and drop updates and some over-the-air updates and other things. These are covered on his website. But if your ESP32 or system is fully bricked and you can't get to the UI or the over-the-air update ability, you're going to have to go down to the command line and manually image the ESP32. And that's what we're going to do in this video. So some notes. I'm using a Windows 11 PC at this point. These notes should work on a Windows 10 machine as well. Everything I'm going to show here is Windows specific. Similar processes and tools are available under Mac OS and Linux variants. There's some coverage of that up on the High Nibble site as well, but those details are really outside of the scope of this video. It's Windows specific. Another note is that this is a complete reinstall of the firmware on the ESP32, meaning if you're have been using your IMSAI 8080 and something bad has happened, you're going to lose configurations, what's called the non-volatile RAM, where the settings for processor and speed on the emulator, etc. live. Wi-Fi settings, that kind of stuff, are all going to be lost and going to have to be recreated. The instructions again are up on the High Nibble site. I'm going to be using the Windows command shell for the work here. This is not going to be a PowerShell shell or some other shell. It's all done directly from the command line. Uh, I've tried using the Windows subsystem for Linux or Unix on the machine. To do this work, I run into issues around getting at the COM port on the machine. The WSL just doesn't seem to want to allow me to connect to ports on USB. In the end, what we're going to need to do here is get basically an emulated RS-232 connection between the Windows machine and the ESP32. And like I said, WSL just doesn't seem to lend itself for that. All of the URLs we're going to look at below are in the video notes, so you'll be able to copy those out of there. The ESP32 PICO-KIT itself uses the CP2102N chipset to establish that serial connection. So the place on that little board where you plug in the USB cable has, like I said, a CP2102N driver chip behind it, and Windows needs drivers specific to that chip to get everything set up as a serial connection. In my experience, Windows Update and Driver Update just don't seem to pick this up, so you've got to manually install it. That means you're going to have to download the driver package from this website here. We'll look at it in a bit more detail later on, and get that file unzipped on your machine so that install package is available. I'm going to be using the Terraterm terminal emulator here. That allows me to get a terminal emulator opened and connect to a serial port on the machine, and that way I can verify my connection to the IMSAI. Python is required to be installed on the machine for that ESP tool Python script to run. There's some instructions in a README, etc., up on the GitHub repository for Python. And of course, you need to download it. A note here is that you need Python 3.7 or later for that ESP tool script to work. A little bit more information on ESP tool Python. This is a Python script that you can run from a Windows command shell that allows you to connect to a serial port and send the necessary information to an ESP32 PICO-KIT on the other end, of course, that USB cable to flash various firmware into the machine. So really, this is all an exercise in command line when we're done in here. And finally, of course, you need the firmware zip file from the High Nibbles website. You can get information on it on this URL and the URL below. I'll let you download, in this case, specifically version 1.12. When you're doing this, you may be on a later version. So this is a complete firmware replacement. So with that said, let's jump in and look at each one of these websites in a bit more detail so we know what we're looking at. So let's take a look at the various web pages we need to bring all the parts together for this. The first one, of course, is the driver that allows the Windows PC to use USB to talk directly to the ESP32 PICO-KIT. This is an emulated RS-232 connection. On the ESP32, there's a little plug where the USB cable plugs into it, and then, of course, comes over to your Windows machine and gets plugged in there. So because Windows doesn't automatically install the drivers for this, either through Windows Update or through a driver update, you need to manually download it yourself. You'll find the link here under the Universal Windows driver. Link here, you can download that zip file to your machine, and then, of course, unzip it so you have access to the files in it. As I mentioned, I'm using Terraterm. Terraterm is just a terminal emulator that can run out of Windows that can connect to all kinds of things, including serial ports or even emulated serial ports. I use Terraterm because I've used it forever. I'm familiar with it. There's Picoterm. There's a lot of other terminals you could be using for this. But it's got to be something that connect to a serial port and allow you to do communications through that serial port. We're going to need Python for Windows. It needs to be Python 3.7 or later. On the link, you'll find a download. In this case, it's for Python 3.12.1. Again, you'll get a zip file from that. You'll need to unzip. I believe it brings down a zip file. It might bring down an executable. But you'll need to be able to run this on the Windows machine to install Python. There's the Espressif GitHub site. Let me actually close this. There's the Espressif GitHub site that ultimately has someplace in here, the ESP32 tool.python script. This will need to be downloaded, and you may notice here there's an ESP Fuse Python script here as well. So in the application for the ESP32 PICO-KIT, specifically for the IMSAI 8080 emulator, there's a set of fuses that need to be burned before this will work correctly. If you're in a more, doing something else with the ESP32, you may or may not need to set fuses. The details on burning these fuses are up on the High Nibble's website. The assumption in this video here is you've got a kit from High Nibble. He's already set the fuses for you, and something's happened. You've bricked the microcontroller or whatever, and you need to re-image from scratch. So we're not going to be doing the fuse work here ourselves. We're just going to be re-imaging, essentially reflashing the ESP32. Information on this is up on the High Nibble site. There's this updating software section, and it gets into how the drag and drop and other methods used if your emulation's fully up and running and you want to do an update. In this case, we're taking the route down this section here in red where we're going to have to manually do it because we can't use drag and drop or over the air. Read through this. There's a lot of good information to have here. And finally, there is the GitHub site for the High Nibble here. This has got the discussions forum on it for support of the machine and other things. And in here, you'll find the download section here for firmware. And in this case, I'm looking at this June 2023 release. I think it's version 1.12. There's notes here. There's some information if you're doing updates about versions you need to move through to get to this version successfully. Like I say, in this case, the assumption is a bricked system, and we're going to, completely do a clean flash from the command line. If you scroll through this, you'll eventually find the download section here at the bottom. We're targeting the file firmware.zip here, and image.zip will be touched later on. Firmware.zip has the files we need to use the ESP tool Python script to actually flash the ESP32. Image.zip contains a set of files that get dropped onto the micro SD card that the IMSAI emulator runs from. If you're looking at some different system for this probably won't apply to you. So I think that gets us through the URLs. Let's jump in and move this forward. So I've gone ahead and downloaded from that page we looked at the driver for the CP210. The zip file came down on the machine, and I've actually unzipped that into a folder here, which we have open here. So this is the folder with the contents of that unzipped file. And specifically, the device manager is going to be looking for this info file here. But let's jump in and take a look at the device manager itself. So to get to the device manager in Windows, you can go down to the search bar in Windows 10 or 11 and type device manager. And you'll find this will come up, and you get this little interface here that discusses all of the devices on the machine and the drivers for them. So when I plug in the emulator system, specifically the ESP32, we can get it into the port here. We should hear it say, there's been a change, and what opened up here was other devices, CP210-1 this bridge device here, and the little triangle here is telling us it doesn't have a driver installed for this. It doesn't know how to use this particular interface. So I'm going to right click on it and do an update driver. And I've had no luck with search automatically for drivers. Like I said, it doesn't seem to find them out on the web. Windows Update doesn't find them. So I've had to download it specifically from the website to install it. So actually, let me step back. I'm going to pick the Browse My Computer for Drivers option here, and this will come up with the path here that says, where do you want to load the driver from? And this is the path I unzipped that driver zip file to. So I browsed to it and selected the path. I click Next here. We'll see installing drivers, and you saw very quickly there the drivers for that bridge device got installed and are done. And if we close now, we should see this interface refresh, which it did, and now we have this options, ports, COM, and LPT opens up. And this says that driver was specifically, was installed successfully and is talking to that ESP32 out there. In Windows, it's using, in my case, the COM3 device. This might be COM1, COM7, whatever on your machine. It's kind of specific to where you are, what's plugged into your machine, etc. But you'll need to know this COM number here because we'll need to know what COM port it's connected to later on. So I'm going to go ahead and unplug the emulator from the RS-232 port. We'll see that goes away. I'm going to plug it back in. And we'll see that it returns here, and then it's connected. So that gets the drivers installed, and at this point verified that at least it's getting installed. So in this next step, we're going to get Python installed on the Windows machine here. From that URL we looked at earlier, I've downloaded the Python 3.12 installation package, and it's sitting right here. And let's go ahead and run it. So this will be a first-time install of Python on this machine. And I haven't done this for a while, so hopefully we'll get it right and it'll work. So I'm going to go ahead, and I believe I want to give it admin privileges while it's running it. And I'm going to want to add Python.exe to the path. And that means from any place in the command window, I can type Python and have the Python environment start up. Without that, we would have to go searching for it. And ultimately, when I run that ESP32-PY, when I type that name in the command line, I want the file association of .py to Python to happen automatically and get Python started. So we've given it both the options here. I want to do an install now. We'll let it take this default path for the install. Yeah, I think that'll be fine at this point. Let me click it. I don't know if you see the pop-up here. It's asking for permissions to go ahead and install it. And we can see here that installation is getting laid down. I don't remember if this will require a machine reboot or not. We'll find out. New to Python, there's an online tutorial. Disable path length limit, change your machine configuration to allow Python to bypass the 260 character. I'm going to go ahead and do that. I don't know that this is necessary for what we're doing here, but things can get buried very deep. And having a path restrict 260 characters, even though that's really long, sometimes can be an issue. I'm going to go ahead and do this. I don't know that you'll need to do it. Again, I'm getting a security warning about do you want to make this change, which I've done. And let's go ahead and close it. I'm going to go down to the search bar and I'm going to type cmd. And what I should see pop up here is command prompt. So we don't want PowerShell here. We want a system's command prompt. And I'm going to go ahead and pick run as administrator just to get the maximum permissions against it. Again, it's asking permissions. And we have a command prompt opened here. Let me see if I can increase the font size a bit here and keep it within the window. If I type path, I should see all of the system environmental paths. And I see in here Python is here. I believe I can type Python. And I get the Python prompt, so we know what to get installed. Control Z, I believe, exits. And I believe Python-fir. No, Python. I want to just see what version we're getting at. I don't remember. It's been a while since I've dealt with Python. Sure, there's a V. Verbose. Well, maybe it gave me that information when I started it. I just don't remember. Python. Yeah, 3.12.1. So we know we've successfully installed it. And we have Python available on the machine. Go to Control Z here. Or hitting Control Z will get you back to the command prompt. So we've successfully got Python installed here. Now, the reason I opened the command shell after installing Python is there's a whole bunch of environmental variables that need to be set up. And if I type set at the command line, that'll show me all the environmental variables that the command shell runs under. And these are things like all the paths to search for an executable. There's just all kinds of other stuff that gets set here that may or may not be needed. For Python to properly work, the path one is potentially the most critical one here. You can see information on the name of my laptop, etc. Anyhow, command shell needed to be opened after Python was installed to at least get the updated path. There is no way in Windows on an open command shell to easily refresh all the environmental variables that the command shell uses. So it's really easy. It's just to open a new command shell. So some quick notes to add here before we proceed. If after you get everything built up to the point in the video and you run the ESP tool Python script and you get some error messages that say it can't include some files, the way I found to resolve this is at this URL, and it's this pip command down here, pip install ESP tool. Come down here, you can see where I ran pip install ESP tool. It brought down a bunch of files. and install them. Pip is the package manager in Python. So this went out someplace on the web, downloaded these things. I'm getting messages here. It's already satisfied because I've installed it previously. You'll get a bunch of messages about I'm downloading files, installing files, etc. I don't know why this is required specifically. Maybe somebody out there does. I've run this from the folder where I unzipped ESP Tool Master 2. This doesn't seem to install a different ESP-tool.python script someplace on the system, but it obviously fixes up some paths or something. I'm not really sure what it does, but it's a required step. It's probably not a correct step, but it gets things working, and I hate to say it, in this case, that's probably good enough. Next thing to keep in mind when you're actually programming the ESP32-PICO-KIT is it needs to be removed from the IMSAI. So you can see here the socket for the IMSAI, and you can see I've removed it. The USB cable will plug in down here and will run off to your PC. If you have the ESP32 plugged in when you go to program, you'll get error messages from the ESP tool Python script that basically say unstable RS-232 connections, and it'll refuse to program. So, like I say, it's got to be removed. Final little note here is when you go to flash the ESP32, there's a button on it that enables flashing. So what'll happen, and you'll see this when I run the script, is the script will run and it'll say connecting, and there'll be some periods appearing across the screen. And during that time, you need to press this button to get the ESP32 into a mode where it can actually be programmed. And I think this is done to keep something malicious from just programming it and taking control. There's also a reset boot button here on the ESP32 as well, and that button can be used to restart the IMSAI emulation or a different thing you've got running in the machine. The IMSAI also has a reset button on the right-hand side in between one of the slots in the metal case. So I think that covers the notes here. Let's go ahead and jump into actually programming an ESP32. So a couple more things to talk about here. I've got the ESP32 master sitting in this folder right here, and I've got the firmware to be programmed sitting in this folder right here. And there's a reason they're side by side, and we'll show that in a minute. Let's jump into the device manager here. I'm going to go ahead and connect the ESP32. I'm plugging in USB cables off camera here, if I can get them to plug in. And let's go ahead and plug it into the PC. And we should get the connection. We saw it here, we saw it refresh, and we're connected to COM3. There's a readme.md file or a flashing.md file included in the firmware that gives some basic instructions here. And we're going to take this command right here and modify it for Windows. It's pretty quick to do. So this is for flashing the IMSAI 8080 software. If you're going to flash the Kremenko software, you grab the one down there. So let me go ahead and paste this in. And the first thing I need to do is point at where the ESP32 Python script lives. And if I go up a folder to here, that should point me at the folder I want to be in. I actually want to be in firmware here. So we're sitting in the firmware folder. If we look up a folder, verify that path, we should find the ESP tool Python script, and we do. So that's the first change I needed to make sure that this was here. The next thing I need to change is this piece right here. So there's a port and the serial port to talk to. So this is coded in Mac OS/Linux style. So it's a device, and there's a device connection. Windows works different in that ports are COM1, COM2, COM3. We know from Device Manager that we're connected to COM3, which is why I'm using COM3 here. And I think this will get us what we need. So our target is an ESP32. We're going to talk to COM3 to find it. We've got a very high baud rate here, default resolve, start, etc., etc. And finally, we get in here to the actual files to be flashed. So there's that OTA data, initial bin, the bootloader bin, the IMSAI bin, and the partition table. And if we look here in the firmware folder, we'll see those files. So there's the bootloader, there's the Kerminko specific bin, the IMSAI specific, the over-the-air data, and the partition table. So I think with that said, I should be able to run this command and hopefully flash my device. So I'm going to copy the command out. I'm going to paste it into the window here. It's not running yet. I'm going to put my finger over that little reset button on the ESP32, not the reset button, the enable button, the program enable button we talked about on the ESP32. Remember, get this on screen here so you can actually see it. On the back of the ESP32, we talked about there's a programming enable button and there's a reset button. And I'm going to need to push this programming enable button at the point where this basically says it's trying to connect. So let's hit return. We can see that connecting. I push the button and release it. We've gotten connected. And we are actually flashing the ESP32-PICO-KIT at this point. So it's chugging along here. This takes a little bit of time. And there it is. So we have written 8,192 bytes, 23,920 bytes, 926, 400 bytes, and 3072. So all four files have been written to the ESP32. So the last thing I want to bring up here is Notepad, or not Notepad, Teraterm. And that did not work. Let me navigate to Teraterm. I don't have it in the path. It's on the C drive at the root in Teraterm. And if I run Teraterm Pro, which is sitting here someplace, now we scroll past it, Teraterm Pro, why can't I see it? If we go ahead and run it, close this back out. It opens up, and in this case, it's defaulting to a TCP/IP connection. I can't actually move it here. We'll do this. We're going to connect to a serial port. In this case, it's COM3. If you've got multiple serial ports on the machine, you could use the drop down here to get to them. Just go ahead and hit OK. And this garbage means I've got the baud rate wrong. So we'll let that buffer flush. Well, that's exciting. Set up serial port. On COM3, I need to set the serial port. I'm going to set it to the 921-600. We programmed that, 8-bit, no parity, 1-bit stop should work. It's on COM3, and we'll do a new setting. Let me go ahead and reset by pushing that boot button. And we're still not getting set up serial port. So at this point, it might actually require 115K. I don't remember. There it is. So I'm going to push the reset button and hold it in reset. If I can. I'm going to well, I can't unplug it at this point. So we do know that we're booting here. We're getting an error message, it looks like, of some kind. Abort was called on core 0. I'm going to unplug it here, and that should stop the scrolling. But what this does tell me is the ESP32 is starting up and trying to run. The chip is an ESP32-PICO. So at this point, the firmware that we program is trying to go out and look at the 8080 emulation hardware, and it's looking for a PSRAM. And we're just sitting here with the chip alone. It's not plugged into the IMSAI. So let's go ahead and clear this. I think it's File, Clear Screen, Edit Clear Buffer. Let me grab the IMSAI. It'll take me a second here. Got the IMSAI emulator here in hand. I'm going to plug the ESP32 back into it. Be sure to get the orientation correctly. The Wi-Fi antenna points towards the RS-232 connectors, and the little USB connector goes towards the side of the machine. Don't that makes any sense. Let me get this cable to plug in here if I can. I'm going to repower it up if I can get it to go. And we see a more normal startup here. So this actually acted like I expected it to. So we can see a power on reset happened. We can see it found the PS RAM, it found 64 megabytes of SP RAM, etc., etc. And this is enough that a Wi-Fi failed to connect. I'm not surprised by that. I don't have Wi-Fi configured. We can see that Z80Sim came up. Z80Sim is the core of the emulator. This is written by Udo Monk, and David is extended on it. David here is the High Nibble. It's bringing back configurations from that non-volatile RAM. It actually didn't lose my previous configuration. That may be because the SD card I've got in it. It's got configurations on it. Your startup here will look a little bit different, but there we are. We've successfully flashed the ESP32-PICO-KIT, plugged it back into the IMSAI, and the machine starts up. So really the next step will be to get the micro SD card image, and we'll look at that next. So at this point, we're now going to format and copy the required files to the SD card that goes into the IMSAI 8080 emulator. I've got the SD card mounted on my PC here. It showed up as drive D. We can do a format. We're going to format to FAT32. Allocation size default. This is a 15 gig drive. I'm going to go ahead and say quick format. And it'll go off and format it, and the format is complete. Close this. We can now drill into this drive. In this folder down here, and the download from the High Nibble site was an image zip. And when you unzip that image zip, you get 3 files. There's the web server contents that's required for both IMSAI and Kremenko. There's the IMSAI emulation, and there's a Kremenko emulation folders. And you can really just copy all 3 of these to the SD card. And that's really it at this point. The SD card now has the proper contents on it. It can go back in the IMSAI. When we start up the IMSAI, we should still be back to default configuration. It appears, as a program note here, as I've done this, that the NVRAM and the ESP32 actually didn't get reset. So some of the configurations seem to come across. I'm not 100% sure of that. But at this point, you should have firmware on the machine, and you should have the software required on the machine for the emulator to come up and run based on whatever build you downloaded. So with that, I don't think there's anything else here to demonstrate. So this finds us at the end of the video. I hope this helped somebody out there. I know that the process I went through isn't perfect. There's probably a better way to do it. Hopefully somebody in the video comments will let us know. If you haven't, please subscribe. Like the video if you feel like it's worth it. And I hope to see you in a future video.